Hello all, in today's video we'll see that what is meant by graph traversal and the different techniques that we can use to traverse a graph. Before we look into the details, let's first understand what is meant by graph traversal. If you remember about tree traversal, which you can find in my previous videos, that traversal basically means visiting every node exactly once. So here two words are important. First is every node, that every node must be visited. This is the first compulsion. And the second is that they must be visited exactly once. Okay. So similar to that, when we talk about graph traversal, it is visiting the nodes of the graph exactly once. So there are two famous graph traversal techniques. The first one is known as the breadth first search and the second is known as depth first search. Breadth first search is abbreviated as BFS, depth first search is abbreviated as DFS. Now to understand these two, first you have to understand that which data structures are used to implement these two traversal techniques. Okay, so come, let's see. Now see, in breadth first search, if we talk about, okay, I'll just write the abbreviated form. If we talk about BFS, you have to remember that for this a queue data structure is used. Okay. Now do you remember what is a queue data structure? A queue data structure is the one in which the element that has entered first is the first one to leave the list or to leave the data structure. It's quite similar to the queue that we see in our daily lives. First come, first serve. Okay, that is the basic implementation of queue. Now if this is the given graph, you can see there is a graph in red. Okay, so this is the given graph. Now if I want to find out the BFS of this particular graph, then first thing that you have to keep in mind is that you are going to use a queue data structure. So now I'll show you. See, say for example, this is my queue. Okay, this is the queue that I am going to use to find out the breadth first search traversal of the given graph. And then there is a result section where you are basically going to print the traversal order. So say for example, you take 0 as the root node. Now listen carefully. If it is not specified in the given question or anywhere that which is the root node, then you can assume any node as the starting node or as the root node. So if I take 0 as the root node, in my example I am taking 0 as the starting node. Then first of all we insert 0 into the queue, this node, the 0 node. Okay. Then this is the insertion. You have inserted the node here as you have visited it. Okay. So now when it leaves the queue, as 0 is leaving the queue, first thing what we have to do is we have to put all the nodes which are directly connected to node 0, which are also known as the adjacent nodes, into the queue. So tell me, which are the nodes that are directly connected to node 0? You can see node 1 is connected to 0 and node 3 is connected to 0. So we'll insert 1 and 3 into the queue. And then 0 leaves the queue, and as soon as it leaves, it means when will it leave the queue? When it is visited and the adjacent nodes are pushed into the queue, then only it leaves the queue. So once it is visited, we write it here, okay, in the result section. Now which is the next node that I have to visit? I have to visit 1. So now as soon as you visit 1, you have to insert the nodes adjacent to 1. So which are the nodes which are adjacent to 1? See, adjacent to 1 you have 0, you have 3, you have 2, you have 5, and you have node 6. All these nodes are adjacent to node 1. Correct? Now among them 0 is already visited. So we are not going to insert it. For rest of the nodes, say we insert it like this. Now see, 3 is already there in the queue. So again we are not going to insert 3 here. But for the remaining ones, we are going to insert them. So let's insert 2 followed by 5 followed by 6. And as 1 is visited now and the nodes adjacent to 1 are inserted into the queue, so this node leaves the queue and we print it in the, or we simply store it in the result section. Okay. After 1 now we have to visit node 3. So which are the nodes adjacent to 3? Come, let's see. 3 is adjacent to 0. 3 is adjacent to 1. 3 is directly connected to 2. And 3 is directly connected to 4. Now among these we have already visited 0 and 1. 2 is already there in the queue, so we are not going to again insert it into the queue. So the left node is 4. So let's insert 4 into the queue. Okay. Now as we have visited 3 and inserted all the nodes adjacent to 3 in the queue, then 3 leaves the queue and we store it into the result part. Correct? Now which node we have to visit next? It is 2. So we visit 2 and we try to find out the nodes that are adjacent to 2. So adjacent to 2 you have 1, you have 3, you have 4 and you have 5. And all these nodes are either already visited or they are already in the queue. So we are not going to do now anything because no node is left now to be inserted. Okay. So we simply visit queue. Adjacent nodes, the nodes adjacent to 2 are already there. So we simply remove 2 from our queue and print it into the, or put it into the result part. Next node we are going to visit, it's 5. Okay. And again now see, there are no more nodes in the graph. So adjacent nodes, even if we see, so adjacent to 5 the nodes are 1 and 2. So these both are already visited. So we are not going to do anything. We are simply going to put 5 out. When 5 comes out of the queue, we put it into the result part. After this, we are going to visit node 6. Which are the nodes adjacent to 6? 1 and 4. Already visited nodes these are. So we are simply going to take 6 out of the queue and put it into the result section. After this, we are going to visit 4. Now no more node is left. So we are simply going to take 4 out of the queue and put it into the result section. And if you print this particular order, then this is equal to the breadth first search traversal of the given graph. Okay. So now if we, so this, I think this order is clear to you how we got it using the queue data structure. Now if you look at the order of insertion of the adjacent node, say for example, first we inserted node 0. Then which were the nodes adjacent to 0? See, come here. Nodes adjacent to 0 are 1 and 3. So previously in this particular queue, you must have noticed that I inserted 1 and then I inserted 3. But see, this ordering is not fixed here. You can definitely insert 3 and then 1. So if you do like this, see, after 0, if we are printing it, after 0, which will be the next node that will be coming out from the queue? It is going to be 3. So you can see here these values will get swapped. 3 will be just after 0. So from this you can understand that this particular BFS is not the only BFS. There might be other combination of nodes, some other order, which is also a valid BFS. So let's see, if we would have put 3 first and then 1, okay, then what would have happened? So 0 you have visited, so we will visit 0 first. If we are just putting the result here, so 0, then we have put the adjacent nodes into the queue, okay, then we are going to visit 3. So which are the nodes adjacent to 3? Come, let's see. Adjacent to 3 is 0, 0 we have already visited, 1, 2 and 4. So after 3, the adjacent nodes are 1, 2 and 4. 1 is already there. So let's insert 2 and 4 here now. Now see, again, in 2 and 4 also you could have done as 4 and 2. So this would have given a different BFS traversal order. Okay. So now let's say, for example, I am taking 2 and then I am taking 4. So after this, we are going to put 3 into the result part. Then we are going to visit 1. So which are the nodes adjacent to 1? It's 0 for sure, 0, 3, 2, 5 and 6. So adjacent to 1 we have 0, 3, 2, 5 and 6. Among these, 0 already visited, 3 is already visited, 2 is already there in the queue. Now I can insert 5 and 6 like this. Correct? Now again you can see that in 5 and 6 we could have done 6 and 5. So the BFS traversal would have changed here. The order would have changed here. Okay. Now let's visit, okay, now since we have visited 1 and inserted the adjacent node, so we are going to put 1 in the result section and 1 also comes out of the queue. Next node we are going to visit is 2. So which are the nodes adjacent to 2? Come, let's see. It's 1, 3, 4 and 5. So adjacent to 2 it's 1, 3, 4 and 5. These all are either visited or they are already in the queue. So if you see, my order will be like this. So my previous BFS traversal was this and my next BFS traversal is this. Okay. So these both are my valid traversals. These both are correct. But say for example someone says that for this particular same graph, my traversal is coming out to be this. Is it possible? See, why is it not possible? Because 0 is connected to 1 and 3. So after 0, it will always be either 1 or 3. It cannot be 2 because 0 is not connected to 2. So after 0, you are definitely going to visit a node that is adjacent to 0. You cannot be visiting a node which is not at all connected to 0, directly connected to 0. Okay, so this is not a valid BFS. This is an invalid BFS, any order. So these two are valid. So here I told you we could have changed the order. Correct. So you can get multiple BFS traversals, but you have to understand that any order cannot be the correct order, but there can be multiple BFS traversals also. So in the next video, I am going to tell you about the DFS traversal technique. Thank you.